This is a video that works out a question from the section on comparing two means dependent samples. The Internal Revenue Service gets frequent complaints that their tax auditors are rude and that harass citizens whose returns are being audited. To try to improve public relations, the government conducted a one-day sensitivity training seminars for the auditors. A random sample of 10 auditors who participated in the seminar was selected. The data below show the number of complaints for each auditor in the sample for the month prior to the training and then after the training. So this is an example of dependent samples. As you can see, if you look at auditor number 1, these are the numbers of complaints, which is 5 before that auditor got the training, and then the second month after the training he had only 3 complaints. So it's the same auditor before and after. So this is an example of dependent samples, and the way to perform the test is different from working with independent samples. Tests that claim that the average number of complaints during the period after the sensitivity training is less than the average number of complaints before the session. So we want to see if the training was effective in reducing the number of complaints. So what we do here, we do the difference. Okay, choose the color. The difference D. 5 minus 3 is 2. 7 minus 8 is -1. -1. 1. 3. 2. -1. -1. 10 minus 9 is 1, and 3 minus 4 is -1. We need to test whether this difference we wanted the difference to be positive or negative. So here's how I would approach this. Let's say an auditor has 10 complaints, just before they do the training. And if the training works, you would expect the number of complaints to be reduced. So let's put a number that is less than 10. So we assume that the number of complaints will be less than 10. So let's make it 7, for example. So here's what you need to do. Subtract 10 minus 7. 10 minus 7 is 3. And then ask yourself, is 3 positive or negative? When you say it's a positive, then your alternative hypothesis should be greater than 0. And this is where the claim is. And then the null is easy. It's less than or equal to 0. So now we set up the null in the alternative hypothesis. So we need to test whether this training works. If the training works, the number of claims after the training should be less. So this is what I did. I came up with a number here, and then I came up with another number which is less and subtracted the 2. And if the difference is positive, then this is what your alternative. If it is less than 0, then your alternative will be less than 0. The next step, guys, for you is to put the data in L1. And you can see that I already put it in the calculator in L1. And we run a t-test. So let's run the t-test. So now watch the calculator work. So we go to Stat, Tests, t-test, Enter. Okay, we have data, so we have to select data. I put it in L1. Okay, and mu0 should be 0 because you're testing against 0. L1, don't change the frequency, and the alternative is greater than 0. Press Enter, and let's hit Calculate. And you get t equal 0.3 decimal places 802, and p-value which is 0.2217, which is bigger than alpha. Alpha is 5%. So we fail to reject the null hypothesis. And if you fail to reject HO, you start with there is not enough evidence at the 5% level of significance to support the claim. That the sensitivity training would help reduce the number of complaints by people who are being audited. Okay, so that concludes the question. So this is a typical question for section 8.3. You always have to make sure whether you're going to put a greater than, less than, or not equal to in here based on the information he gives you. So you just follow the claim, follow the question, and try to make up an example, and based on the example you can decide whether it's going to be greater than 0, less than 0, or not equal to 0.